Hello, everyone. My name is Andrey. I'm from Pressure Labs, and going to give you an introduction to GitWorks, which is our software platform for democratized MBSE. Okay, so just briefly agenda, just overview of the platform, and then I'll present a small case study that we are sort of developing to demonstrate what GitWorks is. What can you use it for? Okay, so just an introduction. Here's our faces. We are a very small team, but we have a lot of expertise in systems engineering, computer science, and software development. We have advisors from NASA, JPL, and ESA, so they kind of help to keep it all grounded in reality. That's me in the middle. So we are kind of spread out across the world, but we have one mission together. We want to make modeling collaborative and accessible to as many people as possible. Our small logo, skunk, and the screenshot. So let's briefly about the motivation problem statement. Things like data knowledge, silos, traceability of data, digital thread, all the things we've all heard about present times. So these are kind of the things that we want to try and solve.
Andrey, just to be clear, you're trying to solve the problem that Graham just pointed out.
Yes, yeah. Exactly. Yes. So we kind of looked at the problem and we identified three fundamental problems here. We have version control and change management and traceability problem. And so to solve this, it means you need some kind of overarching strategy for system description. Otherwise, you get just a jumble of descriptions and disorganized. No one knows what's happening in the description. And we think Git is a good solution for that. Standard in industry, well known by engineers, especially in software world. Okay, another problem is repeatability, durability, and efficiency. So it's very important to perform audits and repeat your analysis in a consistent fashion. So you can, once you perform something, you package it and you can repeat the same and you get the same repeatable results. And of course automation as well. So you increase efficiency, and we think DevOps techniques are very applicable in this case. And finally, interoperability. And for this aspect, we think semantic web technologies are applicable here. So when your system knowledge and data is scattered across many different artifacts, trying to put them all together again. That we talked about before. Trying to have a common syntax to make your artifacts talk to each other, your artifacts, your teams, everyone.
Question. Yeah, maybe I'm too fast, but semantic web, it's like linked data, that kind of semantic web? Yeah?
Yes.
Okay.
Yeah, we'll go.
Okay, thanks. Yeah.
Okay, so we kind of took these three technologies, shook them all together, mixed them up, and we have GitWorks. So we have an early prototype, gitworks.io. You can go and browse in. It's so early that you don't even need an account to click through it. You just, you go on the website, whichever button works, you click. You'll see. Okay, so the overview of the platform. What is it? Overall, we position it as DevOps for digital engineering, for some physical systems, but we're also adding a layer of smart documentation. So if you're familiar with tools like Notion, Coda, or Airtable, I think, so we kind of viewed as smart documentation supported by a knowledge graph underneath. So you have your knowledge base, which supports your documentation. And overall, we envision it to provide an integrated development platform for systems engineers, designers, and installation engineers to manage their digital artifacts, create smart documentation, verify and share their models at speed and with confidence. Okay. So this is the platform architecture. It's a bit complex on the slide, but the key point is that we're relying on a lot of open source technologies that are out there. GraphQL, GitLab, and I guess the key point here is that the whole platform will be open core, which means it's open source and freely available on the base tier, so anyone can use it, like GitLab or GitHub, and some premium features will be available at some kind of monetization strategy. We haven't even done that from yet. Okay, so and it consists of three main environments here. So we have GitWorks projects, commons, and IDEs. So let's look at the projects first. First of all, you get your versioned file manager. So think GitHub, GitLab again. So you have your classical features like branches, issues, merge requests, things like that. Then you also get semantic twin environments where you have an ontology editor, where you can go into modify your semantic web style ontology using either a source code editor or form editor or diagram, like shown on this screenshot. And yeah, you get your knowledge graph exploration and reporting as well, so you can navigate your ontology graphically. And yeah, this is all early interface. And you get your task DevOps task management, inspired by GitLab and CI/CD. So here we are looking at developing adapters for semantically integrating all the different artifacts. So we have a screenshot where you can have your Excel adapters. So you can import data from Excel into your knowledge base. Python, R, Mandelica, Docker, and because we're hoping to, we're going to make it all open source, people will be able to add tasks themselves for their own private project, but also share across the community as well. So, the number of tasks will increase. Okay, so and also HPC support. So people will be able to develop their models and submit task requests for high performance computing in the cloud. So we're kind of reducing the barrier for entry for high performance computing as well. And yeah, so GitWorks Commons also a big part of the platform. This is essentially a marketplace for people to share models, analysis, system descriptions, things like that. It's essentially a package registry, kind of like Maven or NPM, for publishing and dependency management. You can search through this marketplace using Sparkle, or it's based on the knowledge graph of the platform. And of course, we're thinking about IP protected simulation as well. So industrially important data will be protected as well. Yeah, and it'll come with a monetization strategy as well of some kind. Okay, and another aspect of the platform is the IDEs. We are looking at some lightweight IDEs, so using like VS Code on the web. So we currently, one of the first IDEs that we're working on is a Mandelica editor in VS Code, which is nice that Mandelica world, there's only like 3 or 4 well-established tools, so this lightweight editor is a welcome addition to Mandelica world, and also enables collaborative integration. And you have your live share extension, so you can invite people to work on your code. So it's very, very convenient. But apart from these lightweight VS Code kind of extensions, we're also looking at having heavyweight desktop kind of environments in the browser. So you can spin up a virtual machine in your browser window through VDI and Node VNC. And in that virtual machine, you can select the tools that you want to use. And in your browser window, you have your kind of essentially modeling all the tools you need in the browser. Okay, so a brief case study. Yeah, so this case study helps us to sort of guide the development of the platform and ground it in some applications that are relevant to the world. And we are looking at 2 organizations, 2 imaginary organizations. One is the customer of which is designing the aircraft, and part of the design of the aircraft, they need an environmental control system, right? So they need to procure a passenger air conditioner unit. So they put out a proposal for a supplier organization to design and provide this air conditioner unit. So we're looking at sort of across the supply chain, right? So you have customer, supplier, but of course the supplier themselves can be a customer too, right? But in this case study is just sort of one level. Okay. So this is just a flow chart to show how these two organizations interact with each other. You can look through it, but this whole flow chart can be summarized in 3 steps. So system definition, which is where both organizations come together to define the system in question. Step number 2, mostly on the supplier side, they're building the evaluation engine, which would support their development for the air conditioner, and the evaluation and verifications. Okay, so step number 1 in system definition, this is where semantic web technologies come into place, and we use ontological modeling language, OML, for the semantic as our semantic web language. And OML is the language developed by JPL, tried and tested, and it's based on OWL 2DL. And essentially, what you mentioned, it restricts the expressivity of OML to be applied in systems engineering. So it contains a number of modeling patterns relevant for systems engineering. Okay, so we have just a snippet of the code, part of the system definition here. And this is customer who defines the vocabulary and description, so A box and T box. And it captures all the operational and functional constraints, characteristic quantities, requirements, and system boundaries. So in this snippet, really, just briefly, so it contains the concept for air conditioner and the fact that this air conditioner is characterized by a mass. Of course, they can add any other characteristic quantities to it, but just to illustrate it. And they further specify the context in which this air conditioner lives. So they define the atmosphere. So the air conditioner induces the cabin atmosphere in your aircraft. And in turn, the ambient atmosphere, so the ambient conditions influence the air conditioner. So you define your concepts and how they interact with each other. And then the supplier sort of imports that definition of the system from the customer, and they elaborate on top of it by defining proposed constituent components and connections and configurations and controls, and they extend the previous code by adding components like compressor, heat exchanger, and they specify so air conditioner now not just sort of in abstract, it contains components of its own, so compressor, heat exchanger. And they define further things like air pressure, air temperature, things like that. So once, all right, yeah, just briefly. So in the interface, you don't necessarily need to know the syntax of the language of OML. We are providing form-based editor as well. So yeah, in reality, people wouldn't need to know the syntax of it. You would provide means to edit it without actually coding. Okay, so once we have the system definition defined in OML, in semantic sense, we can what we can do next is we can employ our some of the adapters that we provide to perform a model transformation. Okay, so an example here is transformation from OML to Modelica language, and we have this diagram to show kind of how things map from one language to another. And Modelica is the object-oriented language with defined semantics, so it's really easy to transformation. And this adapter helps with, even selecting the appropriate Modelica components to describe your system. It'll become a bit more clear in the next slide. It's a bit complex, but the point is that from your semantic system description, you can then generate a model which you fill in with the physical description. of the system, and you get this Mandelica model, which allow you to do the calculations in the physical text, right? So you have pressures and temperatures computed under given requirements and constraints and given scenarios that you define in the OML language. And of course, you use Git and VS Code and any Mandelica IDE you want to version control and to branches and all these things for your system development. And finally, you can use DevOps methods like CI/CD, and you can generate these reports automatically. And this table just shows you that for given scenario, given requirement, which component fulfills certain requirements or which ones it fails. So we have some ticks, we have some crosses, so we kind of can trace and see how our design evolves over time at the given constraints. Okay, to conclude, yeah, so this is our vision for GitWorks platform. We designed it to address all the major challenges of MBSE, and we do it by combining DevOps with semantic web technologies. And we have a small case study that we're working on. Of course, we're thinking of more case studies, and we're thinking of more complex systems and how can this be scaled up as well. Yeah, we have plans for the future. Yeah, big part of it is developing the adapters between different tools so that industrial partners can work in their tool of choice and then use adapter to make the bridge between the two worlds, and hopefully use our platform as sort of the center sort of single source of truth. Yeah, we are working with Hans-Peter de Koning, which you saw in one of the previous slides, who is very involved with SysML2 development. So he's helping us with that as well. Yeah, user interface, we're working on it. And yeah, more use cases for us.
Yeah, thank you very much.